It is my privilege to introduce Chris Pakla. And Chris is the director of the Regional Science and Math Center.
Math and Science.
The Math and Science Center, which is affiliated with GVSU. And that center provides teacher education and also student opportunities in relation to STEM. So they seek to make teachers better educators about STEM topics, and they seek to create opportunities for high-impact experiences for students. The whole idea being that we have a combination of things that incentivize and create a desire for students and teachers to get more people into STEM careers. Chris has a very interesting background. He was actually an undergraduate and graduate student at GVSU. His undergraduate degree is in math and physics. And then he did a master's in, was it education?
Leadership.
Education leadership.
Thought I wanted to be a principal.
I wanted to be a principal. But he then went and did teaching and ultimately got his PhD out at George Mason University in educational policy. And then has returned to Grand Rapids, thankfully, and I'm glad you're back, Chris. So we like to attract that kind of a talent. But Chris is now serving as the director of the Michigan Regional Math and Science Center and is moderating our panel today, which is wonderful because he has a deep subject matter knowledge. And Chris, with that, I would like to turn the stage over to you, and thank you so much for agreeing to do this.
Yeah, thank you, Elliot. All right, well, welcome to everybody here. We're very glad that you're willing to join us here at the end of the day of lots of learning. I'm sure it's been great today. We've got a great panel up here today that's going to be talking about some ideas in STEM education, looking at how there's an intersection between STEM education and big data and how we really take that into the next stage here, building on the work that we've already done and moving it forward in those gaps that we've got. So first, to my left, and now your left, because I'm looking the same way that you're looking, is Dr. Kelly Christopher. Dr. Christopher is a product of Grand Rapids Public Schools. She attended North Carolina A&T State University, a historically black university, where she received her BS in Agricultural and Biosystems Engineering. She received her MS and PhD in Agricultural Engineering from the University of Illinois at Urbana-Champaign. When Dr. Christopher received her PhD in 2005, she became the third black woman in the world to get a PhD in that particular field of study. She also has served as the national president for Alpha Epsilon Honor Society, for the Honor Society for Agricultural Engineers. Next, we have David J. Corliss with a PhD in statistical astrophysics. David J. Corliss has more than 20 years of analytical experience in the automotive industry. Dr. Corliss is the founder and director of Peacework, a volunteer cooperative of statisticians, data scientists, and other researchers applying analytics to issue-driven advocacy. He is active in the American Statistical Association, including past president of the Detroit chapter and writing a monthly column on data for good for Amstat News. Next on stage, we have somebody that you might recognize from the keynote earlier today. Dr. Sheldon H Jacobson is a founder professor of computer science at the University of Illinois at Urbana-Champaign. His research interests span theory and practice, covering decision-making under uncertainty, with applications in aviation security, public health, computational redistricting, and sports analytics. His research has been widely reported and featured in the national press, including the Washington Post, the Chicago Tribune, the Los Angeles Times, and the Boston Globe. He's been recognized with numerous awards, including a Guggenheim Fellowship, and is an elected fellow of the Institute for Operational Research and Management Sciences and the Institute of Industrial and Systems Engineers. And last but not least, we have Dawn McCotter. Before joining Van Andel Institute for Education in 2016, Dawn spent 13 years as a high school teacher, devoted to creating a classroom where curiosity, critical thinking, and creativity thrive. As teacher programs manager, Dawn supports teachers in implementing inquiry-based teaching and learning. She's a passionate educator who wholeheartedly believes that all students will succeed in a classroom environment supportive of collaboration, risk-taking, and valuing of ideas. All of their contact information is up on the screen if you want to follow up with any of them afterwards. I'm sure they would be very glad to answer any follow-up questions that you've got. We'll have some questions here for the panel, and then with about 15 minutes left today, I'll invite you to come take a cue at each of these microphones here to ask some questions of the panel that you might have. We'd really encourage you to think about some questions that you might have. That's why I'm telling it to you early here, so you have some time to think about what you might ask our esteemed panelists here. So first, a question for everybody. We know that STEM stands for science, technology, engineering, and mathematics. But STEM more broadly is understood to be more than just these 4 core content disciplines and includes connections with other content areas, skills, and mindsets. Can each of you, one at a time starting over here, spell out to you what STEM means in the work that you do and how big data does or doesn't align with STEM in your mindset?
Thanks for allowing me to go first, so I had no chance to think about that. Okay, so you said, what does STEM mean to me?
Yeah, what does STEM mean to you?
That's the first part.
Yeah.
The work that I do now, and as you mentioned, my education is in engineering, but I got to the place in my career where I realized that there were lots of people who could do the engineering work that I was doing, but there weren't a lot of people that were willing to influence the next generation, to become STEM professionals. So I decided to go into education. And so STEM to me is really an opportunity for the 21st century for our students who want to have opportunities to especially raise themselves out of poverty. It's a very good field in that regard. So, and what else? Okay, so what does STEM mean to me?
What are the connections between STEM and big data? Other than the fact that big data is the M.
Well, I know in my profession, sometimes to create a case for why resources need to be made for students, people of color, data is important to that. So there's definitely an opportunity for big data to influence the work that I do as far as creating giving me ammunition, and I get supposed to get the resources to the students that need it.
Great, thank you.
Okay.
David?
When I think of STEM from the perspective of someone working in industry, I've been a university professor in the past, so I've seen both sides of that divide. Of course, in an event like this, there's so many people who are students. They're looking at the workplace. You've also got people in industry looking at the students, and I see a lot of disconnects. For me, STEM education is around creating those basic core skills, and so it goes beyond the science, technology, engineering, and mathematics. Every good person, every capable person in industry is going to have to be a good communicator. Is going to have to be able to think, write, and speak clearly. One of the weaknesses we often run into in industry is people can do the math, they can write the code, but the ability to explain and communicate the methods, the results, and how they're to be used is very important. And so STEM is a broader set of skills that includes reasoning, communication, and effective presentation methods. And that's becoming all the more important in increasingly knowledge-driven economy. The ability to have STEM education is core to all of us. It goes beyond, that person's an engineer, that person's a scientist, they're working in this particular area. It's something that's becoming an important part of broader literacy. H.G. Wells, 100 years ago, said this of statistics. I'm going to say it of STEM, that at a basic level, he wrote that statistics would someday be as necessary to a basic education as the ability to read and write. That day is today. And the STEM education is something that every person who wants to fully participate in society, not just to mention get a good job, it's something that everybody needs. And it's that broader set of skills.
That's true.
Great. Sheldon?
When I think of STEM as a verb as opposed to simply an acronym for science, technology, and engineering and math, because unless you're doing STEM, then you aren't doing STEM. It requires us to take action, and the students that I engage with in our institute, which focuses around STEM, we focus on the doing. And just because of my interest and background and the kinds of problems we work on, all of them ultimately will revolve around some kind of data analysis. So we have a bias in terms of what we do. That's where it fits in our own activities. Without that opportunity to translate ideas which are fairly abstract in classes and bring it into something that is very real and tangible and see their work produce very tangible societal impact, then STEM is like a tire which has no air in it. But when you pump it up with action, that's when things happen.
I like that visual. Yeah. Dawn?
So in K-12, STEM, like the acronym science, technology, engineering, math, I think there's a lot of misconceptions with that. As educators, you think that if I teach STEM, it's hands-on. Well, it's not just hands-on. There's more to it. And it's not just science and then throw in a technology tool. No, it's a seamless, it's a mindset. It's creating opportunities for students to be able to think and act like scientists, like engineers, like mathematicians, breaking down those silos. One thing that we're very passionate about at the Education Institute, just up the hill here, is giving students these real-world opportunities to make a difference, but learning the content they need to learn, the science skills that they need to learn, the engineering, that design thinking, that iterative process, and doing that not silotized, but doing that together. I mean, we've seen STEM has now turned into STEAM, you can throw in the art, and then there's STREAM. Well, I challenge is you can take any content area with that mindset of inquiry and creative and critical thinking and problem solving, and turn it into an authentic learning experience for students to make them successful in the 21st century.
So we've heard that it sounds like there's a lot of threads here about the ways that big data and STEM connect together. We've heard from Kelly here that it's kind of that driving force, the why, right? We can use big data and the results from big data to give that impetus why. We've heard a little bit about kind of how the hands-on experiences, the doing, the kind of the baseline knowledge of STEM are so important. It strikes me as a really good opportunity for applications of big data to be used in STEM fields, especially as we're starting to think about STEM education. So does anybody have a thought about that? The applications of big data, having students use hands-on, do that kind of work with the data that's out there, kind of getting comfortable with the data, seeing the noise in the data, all of those different things.
What data provides is in some sense a workshop for STEM. That data of itself isn't STEM. The question is what you do with it. And if you think about the different facets of STEM, especially the math, which is my own personal bias, obviously, data gives you the opportunity to get into the sandbox and play with the toys. So in some sense, sand in the sandbox and the toys represent the STEM activities. And it's the environment that we create that facilitates that. You can just throw toys around, but children will gather in a box, and they will become a community, and the toys are part of what motivate their activity. In many ways, it's exactly the same thing with data. Data can become the driver to the activities around STEM.
I agree with that, and I think the more that we can bring that relevancy to K-12, to the classroom, of real data sets, data that's been procured by mathematicians, by statisticians, by scientists, and bring it into the classroom and show them that. It just ups the engagement. They're not given fake numbers and fake scenarios. These are actual people, professionals working in actual industries, collecting this data to make the world a better place. Let's use it.
There's a popular phrase these days that data is the new oil. I think data has a lot in common with oil. When you first encounter data, it's locked away someplace you can't get to. You first get it in your hands, it's really dirty. It has to be refined. And then you have to get it out to the people who actually need it and use it.
Right.
In many ways, data is a lot like oil. The difference between oil locked in the ground, it's a resource, maybe it's useful, and data that's making a difference in people's lives. The difference is STEM. STEM is what connects the raw resource of oil in the ground and brings it through all those steps and turns the lights on. And without hands-on STEM education, people will never learn how that process works or how to make it happen. It will stay locked in the ground.
Sheldon, your work focuses a lot on the intersection between STEM fields. We heard a lot of those different connections earlier today, looking at novel approaches to data on health, aviation, artificial intelligence. But STEM gets a lot of flack sometimes for taking the focus out or over the humanities. Is it an either-or situation between STEM and the humanities, or how might we be able to see it as a both-and?
The media like to make it sound like it's an either-or, but I think it's actually a union. That there's no reason why someone who's being educated in the liberal arts cannot complement their education with STEM activities. One of the things that we've done at the University of Illinois is we've created programs called CS plus X, which have now become more ubiquitous. And it's basically having a joint major between CS and other fields, where X can be philosophy, X can be many fields in the humanities, in agriculture. And this has created a completely new group of educated young people who have the basic understanding of computing and STEM activities, but are really grounded in the humanities and the liberal arts. This is something that is now, we were one of the first schools to actually do this in the United States, and now it's becoming quite pervasive at universities, saying, you know, they're connecting themselves, because the humanities are in a struggling position. My wife likes to kind of stress the humanities of education, and she's had a very strong humanities background. She's also a physician now, of course. What we try and do, and what I try and encourage to my students, is do things that enrich your life in many ways. I give them books to read, which have nothing to do with STEM. I encourage them to take steps out. I encourage them for communication and to be able to speak clearly. There's a wonderful article in the last 24 hours, I believe it's in the Chronicle of Higher Education, of training students by being stand-up comics. And so being funny has some STEM value because it enables you to communicate and translate very technical ideas to non-technical audiences. The 30-second elevator speech. You should be able to give it so your grandmother understands it. Now, hopefully your grandmother is not a STEM PhD. Assuming she isn't, then you should be able to explain anything in 30 seconds for her to appreciate it.
Great. Kelly, an article on your work that I found highlights some of the exciting programs that you've worked on throughout the years. Quoting from that article, it says, programs include, quote, cool chemistry concoctions where students identify acids and alkaline solutions using cabbage, learning about polymers by making slime, and investigating molecules by making bubbles. In that, you maintain that getting students, especially girls, excited in the STEM fields early on is critical to making sure that they don't leave those fields. As part of the work that I do as the MySTEM Network, I hear from a lot of folks that they just are never good at STEM. They're a right-brain person or they're a left-brain person. They can't go into STEM because their parents weren't good at STEM. But isn't STEM for everybody? And if it is, how can we make sure that we get those students early on and keep them going strong?
Well, I mentioned in my talk earlier that when I was growing up as a girl, I wasn't interested in math, and I wasn't good at math, but part of that was because I didn't know any women who liked math. It makes a difference. Your role models make a difference. And so perhaps sometimes, even despite our best intentions to encourage people to go into STEM, until they see someone that looks like them, someone that they can identify with in that type of profession, it just doesn't click. And so perhaps, you know, like with the students I work with, almost all the boys want to be a professional athlete, but that's what they see as a successful person of color that becomes an athlete. So we have to be very careful about who are, you know, and this is not only for students who are students of color, but just all students, that they see a diverse representation of professionals that are in these fields. So the fun things that we do, I mean, you can make activities fun for any kid, but in addition to making it fun, they still need to see themselves in that profession, and it's hard to do sometimes. So.
Yeah, great, thank you. Dawn, at Van Andel Education Institute, you work with a huge variety of stakeholders in the work that you do, from K-12 students to teachers to parents to community members. Talk to me a little bit about how you engage people in STEM education at that whole range of pre-K to gray.
Sure. So at the Van Andel Education Institute, we have both student programs and teacher programs. In our student programs, we have kindergarten through 12th grade that come in for field trips. They'll come after-school programs, and we have science on Saturday opportunities. And so we really try to involve the community and the schools locally and get the kids in. And we really focus on we have an instructional model we use that has been vetted and built upon the practices of scientists that work up at the Research Institute, just a couple blocks up the hill there. And we take them through the science inquiry process, but also focusing on a classroom culture, a rich learning environment, and the scientific habits of mind. And we take all of our students through that process, through that inquiry, where we have 4 hallmarks for inquiry. And this is the same things that we teach our teachers that go through it, is the students, number 1, do not know the answer before they start. Which is a huge change, because traditionally in K-12 science education, a lot of the experiments were done after they learned the content. And in inquiry, we flip that. We want students to construct meaning. Second, they are constructing meaning with their teacher through journaling. Third, they're working just as hard as the teacher, or harder. And fourth, they have choice. There is a choice in that learning process, whether it is the choice in how they represent their data, a choice in what variable they want to test, or a choice in what actual experiment they want to do. So that is how we take our students through our programming, and then we work with our K-12 teachers the same way through that same process and teach them the skills to do that. Now at K-5 looks a lot different than at 6-12. And so what we found in working with teachers at the K-5 level in inquiry-based science and STEM is that that's not their content strength. They have to teach every single content. As a science teacher, I knew science. I knew earth science, I knew geology, I knew some physics, and I could teach that. And I could do a pretty decent job, but you asked me to go teach those 39th graders now ELA and teach them history and teach them art. I couldn't do that. And these elementary teachers are doing that. And so we need to find a way to work with those teachers to give them not only the skills to teach inquiry science, but the confidence to teach that content, because it's not what they went to school for. They went to school for everything. And so we provide those resources for that too.
Great. David, earlier we chatted about a 2013 article that you got published in Cranes Detroit, and I went and looked it up. And the first line of that really caught my attention. And reading from that, it says, they say that admitting that you have a problem is the first step. My problem isn't finding work, it's finding qualified workers. And last week, the Michigan Department of Labor Market Information and Strategic Initiatives published their monthly outlook on jobs in the state of Michigan and highlighted that we still have this problem in the STEM fields. We need to fill currently over 10,000 jobs in the state of Michigan in the STEM fields. Probably unsurprising to most people in this room, STEM jobs in Michigan are higher wage, on average $38.23 per hour versus $17.20 for non-STEM jobs. They've increased by 14% compared to 8% in the same time period, and they require more credentials and schooling than other jobs. But we do know that the job market today is different than the job market in 5 years and in 10 years and in 15 years, when some of our K-12 students are going to be hitting the job market. So how does the work that we do in STEM education really prepare students for that lifelong learning and flexibility that's going to have to be there as students are entering the workforce and experiencing things that we have no idea what that job market's going to look like?
It's been my experience, a great question. It's been my experience that technology and jobs and job descriptions have a shelf life of about 5 years. Think about how you did your job, whatever your job is, think about how you did it 5 years ago. It wouldn't get you an interview today. Things are changing constantly, and so the focus in education needs to go beyond, we're gonna teach you to code Python, or we're gonna teach you to run this set of algorithms. Problem solving and learning to learn, and being able to, if you're going to be in STEM, being able to use all the different resources, government resources, industry, going to conferences, academic resources, and the academic to industry research pipeline, all of those become critical parts. We don't usually think of those as STEM skills, science, technology, engineering, mathematics, but where was research in that? Or being able to communicate well. Where's problem solving in all of that? We don't list that as one of the traditional things. The focus of STEM education is, we're going to teach you how to do this thing. But what we need to be doing is to create learners and people who will always be learning. That means the discipline of learning. Problem solving, algorithm development, ability to write an algorithm. The code will change, the languages will be different, but the step-by-step process of telling somebody else how to do things, especially if that somebody else is a computer, and to be able to develop algorithms, these are the core skills we need to go beyond. We're going to teach you this subject, we're going to teach you this subject, to the core skills that are going to continue that trajectory. And simply teach the students, if I would suggest, that technology does change. Now, I'm a bit of a dinosaur. I happen to like Fortran. Anybody write Fortran? Anybody still write Fortran? Well, more people should be writing in Fortran because they're very, very efficient, computationally efficient algorithms. And in the big data world, what's old has become new again. But see, that's the thing. It's that technology changes. That what you learn now isn't going to be what you're going to need to know in the future. And so the real skills we're learning are problem solving and thinking a problem through and being able to present the results to an audience that really doesn't know and doesn't care how you got the answer.
So rapid fire, top skill that ages well, right? We just talked right here about the skills, those core skills that are not the content pieces, that are the ones that will help our students get ready for that next stage. What's each of your top skill that would prepare your students for their jobs in 10 years, 15 years?
Critical thinking.
Okay.
I'd agree with you.
The word that came to mind was logic. Same.
Well, I work with a lot of middle school students, and they're lazy a lot of times. So, you know, a lot of them don't want to do the thought processes. They don't want to think about this stuff. They just want you to tell them the information so they can move on to the next thing. There's a work ethic, I think, that is just important. And I don't know if it's something that you really teach or just something that you instill. And that's what I really seek to instill with my students, is that it's important to work hard. All of these different jobs that are it's not going to be the same. As you mentioned, we can't prepare someone for a job that doesn't exist. But if you're a hard worker and you've developed that work ethic, you can be successful, in any field. So.
Great. We're reaching the audience participation section, so feel free to jump up if you've got questions. I've got more questions that I can ask, but if I see people jumping up, then we'll go. So we'll start right here.
So the last question kind of segued into a very interesting point. Rapid fire, you asked, apart from STEM, what is the one skill, right? And is it a skill or a trait? Mm-hmm. Is critical thinking a skill or a trait? And are traits developable? Can they be developed, right? Can a good work ethic be developed? Can resourcefulness be developed? And can we embody that? Can we build that into our STEM articulation programs?
That's a really great question. We spend a lot of time working with students and teachers on that, on basically brain training, and critical thinking is what I chose, but working on strategies and tools that you can use in your classroom to teach critical thinking. And it's not as if, oh, it's critical thinking time. We want that seamless. We don't want the students to silotize that either. We just want to be a part of their process. But there are strategies that can be done, and then we work with teachers on to promote critical thinking. So yes, it is definitely a malleable skill that the students will learn.
I'd like to make the distinction between education and training in higher education and even in K-12. Education has a much longer shelf life than training because things change over time, as you quickly pointed out. But education is a process, and that's why I think of STEM as a verb, simply because it's the process of acquiring, but it's not the end result of the knowledge you acquire, it's the process of doing that. While training is getting certain skills, which may evaporate.
One of the problems I think we're facing in education today, especially in STEM education, is what I'll describe as the inoculation theory of education. I've had algebra and I don't have to have it again. Beyond the content of any individual course, we've talked about some of the quote, soft skills that are needed. But what it points out in education is it isn't enough to add new courses or to change the content of the course. It's how the curricula are designed, how they're approached. It has to be an organic, from the ground level, from the roots up, redesign of our education program that gets away from traditional educational methods and even course design and curriculum design to be able to create lifelong learners.
One thing that I found, it's a little bit different perhaps from your experience, but one thing that I found in general is that whether it's a program, it's a curriculum, and this is talking about changing students and their trajectory, I have not found any particular curriculum to be successful in changing people. People change people, not curriculum. Not, your relationship that you build with a student is more important than what you're actually teaching them, because they learn so much from you as a person, and they can be inspired to do other things just from their relationship with you. So I'm often asked, which curriculum would be best for urban students? Or it really is. It goes beyond that, because there's so many. We don't lack curricula. Like, there's plenty. There's hundreds. So what we really lack are the people willing to invest in people's lives to help them grow.
Yeah. So one of the last questions that I've got for the whole panel builds on something that Kelly said earlier, this idea that one of the ways that we can get students to engage in STEM when they're coming from historically oppressed or underrepresented groups is by showing them that they can be going into these fields, they can exist in these fields, there are role models. There are a lot of barriers aside from just the number of people that are in those fields. So what are some of those barriers, and how can we as a group in this room, or big data group in general, or STEM education in general, how can we address those? What can we do?
Well, first I would say that we have to understand that it is a commitment. It's not something that is going to change. It perhaps won't really in our lifetimes, we may never see that diverse utopia that we would want science and engineering to be. But we still have to be willing to invest in, I'm the executive director of the STEM greenhouse. I'm all about the seeds, planting seeds. Even those of you here today, my hope is that you would take something away from this that would help you spread this message of how we can get more students, a more diverse population of students. So in terms of barriers, let's just say a student comes in for a coding day. It's wonderful, great experience. They leave, they get home, they don't have lights on. There's a lot of barriers. All of a sudden, you have totally forgotten all of the computer science that you've learned because you're just trying to survive. Or, we'll take a child, they'll have a week-long camp at a university. They're in middle school. And then we'll say, good luck becoming an engineer. I hope that week was enough for you, as a 12-year-old. And we really expect things to change. So I would just say, I would really love to see this community decide we're going to invest long-term for growth. And we're not necessarily going to expect a lot of diversity next year, but we just know that we're planting the seeds for the future.
Great.
One of the greatest challenges we face in STEM education, you talk about barriers that are in place, is one that we haven't talked about just yet. It's one that doesn't involve students at all, doesn't happen in the school, can't be fixed with curricula. It's a limitation actually in the students' parents and their literacy. Think about something we see a lot. If little Johnny can't read, that's a really, really big problem. But if little Mary can't do math, well, math is hard. We hear this a lot. And so it's a social acceptance of this particular subject, STEM subjects being difficult. People are allowed to fail rather than saying, this is a concern we need to address. And the limit, the specific limit we run into, is the STEM capability of the children's parents consider. You talk to, 5-year-olds, 6-year-olds, 7-year-olds, what class you like in school, all of them can count, by second A they can all add and so on. It moves right along. There's no difference between early STEM education and other fields until you hit roughly long division, which parents very often don't remember how to do. When the content that the students learn in class exceeds the parent's ability, that's when we see that split, that difference between STEM capabilities and other areas of learning. And the thing that we need to target in part, and I'm not saying we can forget about the rest, one of the greatest barriers we face is the general scientific literacy of the students' parents. And so when we think about STEM education, we really, really, really need to think about educating the entire community, because that's what's going to make those students succeed.
Great.
One of the things I've observed is I certainly understand their role models. I suppose if I was going to follow my role models, I'd be running a Jewish delicatessen today. Because nobody in my family got anything beyond, my father had a bachelor's degree, my mother barely got through high school. There's not a lot of higher education. I didn't have particularly good role models, but I was given opportunities. And one of the things that I've learned now in dealing with people is that sometimes a person needs permission to succeed. Sounds kind of strange. You think, well, everybody wants to succeed. Some people don't know that they can succeed. And I always make the assumption with all my students, whether they're from underrepresented groups or majority, that they can succeed, that the only person who is holding them back is themselves. And I will do anything to help them succeed if they are willing to put in the effort. So I've graduated 23 PhD students in my career. I have 6 right now, and around, I think, 10 of them, 10 or 9, are from underrepresented groups. And I've never used any of their background or their limitations from the past as an excuse for them not to succeed. I've had a few that have left me because they were not willing to do what it took to succeed. But I have always given them all the same opportunity, and I think that's been critical.
I would agree with that, absolutely. And I'm going back to, Kelly, what you said about the rapport piece and that connection. And I know there's an old adage that's a student doesn't care what you know until they know you care. And that's so true. And so we can talk about different populations and different underrepresentation, which is incredibly important. But it comes down to that teacher in that room and the connections that teacher has with their students. And if they believe that all their students can succeed, their students will know that. And they will rise to that challenge if that teacher is providing them those opportunities to be successful in a STEM field. So I really think it boils down to the rapport, those connections, and then bringing in those engaging real-world types of experiences and giving the students choice for letting them succeed.
Now, I do want to make a point that there is a difference between providing the same opportunity for everyone and equity, because equity recognizes that people come from different starting places. And so when you give everybody the same thing, but like my experience at University of Illinois was different than a white student's experience at the University of Illinois. So if a professor gave us both the same things, are we really equal? Because I'm by myself and they're not. Right. So there are things that we need to recognize that we have to do more. That's the reality. We can't just give everybody the exact same opportunity and say go for it, because it's still not equal. Like when I I took a lot of civil engineering classes at the University of Illinois. There were no female bathrooms where the classrooms were. Like, it was like Hidden Figures where you have to run to on the other side. No, it wasn't that bad. But like you had to go to where, on the top floor where all the secretaries were, they have one little bathroom for, you know. It was like, we don't even expect you to be a student here, so those type of things make a difference. And so, and I think I had a great advisor, but at the same time, I never felt that anyone was perhaps giving me anything that would make my situation more equitable. I just had to suck it up and just do what I had to do to get out of there, so.
So the very last rapid fire before we hand the stage back over to Elliot to do some closing remarks. One word that signifies something that you want the audience to take away from what we talked about today or your feelings generally about STEM education. One word that signifies what you want the audience to take away.
One word is very hard.
One word. And
It
it could be a
That's critical
collection of one
thinking,
word.
by the way.
A phrase?
Yeah, a phrase is fine. One word or phrase, yeah.
I'm going to say hope.
Okay.
Holistic.
Perseverance.
It's just better to do something than nothing. That's all I can say.
Okay.
Do something.
I hope you'll join me in the audience with thanking our panel that we have here today.